which basically means they're used to define how the assembly parts fit together. As you add mates to an assembly, you'll define the allowable directions of linear or rotational motion for components. Once created, mates allow you to move a component within its degree of freedom to visualize the assembly's behavior. It's important to note that mates are solved together as a system, so the order in which you add mates doesn't really matter since all the mates are solved at the same time. To add mates, click Mate in the Assembly Command Manager. SOLIDWORKS then asks you to select Entities to mate. In this example, I want these two circular edges to be coincident with one another. Once I make the selections, SOLIDWORKS decides which mate I'm most likely trying to apply and positions the components to preview that mate. An Options palette also appears next to the selections, so I can quickly change the mate type, reverse the mate alignment, undo the mate, or accept it. Since the frame component is fixed, I can now drag the driver component to move it within its remaining degree of freedom. This brings me to an important point. The first component added to an assembly will always be fixed by default. To free up a fixed component, simply right-click it and select Float. The F prefix next to the component will then be replaced with an underdefined prefix. Conversely, right-click an underdefined component to fix it. Also note that the coincident mate I created is now listed in the Mates folder at the bottom of the Feature Manager. From here, the mate can be suppressed, deleted, or edited, just like any other SOLIDWORKS feature. With the Mate Property Manager open, when I click OK, the Property Manager remains open so I can continue to add mates as needed. As you can see, the standard mates function similar to basic sketch relations. I can make selected faces, points, or edges parallel, perpendicular, tangent, or concentric to one another. I can even add linear and angular distance mates. I'll mate the driven component to the frame next, but this time I want to mate faces using a coincident mate and a concentric mate. Note how the two mates give me the same result as the concentric edge mate I created earlier, illustrating that there's often more than one mate option available to create the same component relationship. Not only do mates tell components how to relate to one another, but they're also used to define motion dynamics for an assembly. If I activate the Move Component command and toggle Physical Dynamics, you can see that the assembly behaves as expected when I rotate the driving component. Throughout the upcoming lessons, I'll show you different ways to access mates, as well as some of the assembly tools that can be used in conjunction